Hi guys, welcome back. Today we're going to be doing sequences and focusing on how to find the nth term. For your GCSE exam, there are two sequences you need to know about. One is linear, the other one is quadratic. It depends which paper you're doing. If you're doing foundation, you only need to know how to do linear. However, if you're doing higher, you need to also be able to do quadratic. However, don't just skip on to quadratic. If you're not so sure about how to do linear sequences, make sure that you watch this video, get a clear understanding of how to do this, and then move on to the quadratic. I've split the sequence section into two different videos. This video will specifically be about how to find the nth term of linear sequences. The other video will be about how to find the nth term of quadratic sequences. However, if you're on a higher paper and you're not really sure how to do linear, make sure that you don't skip linear and just go to quadratic because you think you're doing a higher paper. Because if you're not able to do the easy sequences, then you're definitely not going to be able to do the harder ones. So make sure that you completely understand how to do your linear sequences and then move on to your quadratic. Anything linear is always in the form of an plus b, where a and b are just coefficients and n can take any value from 1 all the way to 1,000 or 10,000, literally any number. So if you put n equals 1, this should give you the value of the first term of the sequence. If you plug in 2, it should give you the second value, which should be the second term of the sequence. If you put n equals 3, it should give you the third value, which is the third term of that same sequence. So let's take a look at this sequence. In this case, n equals 1 gives you 2, so n equals 1 means the first term, n equals 2 means the second term, n equals 3 means the third term, n equals 4 means the fourth term, n equals 5 means the fifth term, and obviously it can carry on until the 1,000th term. N can only take whole number values, so 1, 2, 3, 1,000 or 10,000. And it can only take whole number values because you can't have 1.5th of a sequence. You can have a second and a third term, but you can't have 1.5th. So that's why n in terms of linear sequences can only take whole number values. So you can take 1, 2, 3, 4, 5 all the way to 10, 1,000, 10,000, any, just not a decimal number or negatives or even 0, because you can't have a 0th term of a sequence. You can only have a first term, second term, third, and so on. So how do you actually find this formula, which would then help you find different terms of the sequence? We've got a sequence here. Obviously, we've got the first term, we've got the second term, the third term, the fourth term, and the fifth term. That's really simple. We'll also be able to find the sixth term. How? Well, every single time you're adding 2, so the next term of the sequence you're going to be adding 2 again, so it will just be 13. So that will be the sixth term of the sequence. That's well and good. However, if somebody asks you to find the 50th term of the sequence, you can either sit there for ages, try and work out every single term until you get to the 50th, or there's a shorter and simpler way. So you just have to follow sort of a step-to-step guide again, and if you follow this for all linear sequences, you should be able to find the nth term of any sequence. So here's your sequence. Step number 1 is to always write down the term number above each term. It just makes your life a lot easier and you can clearly see what you're doing. The second step is to find the difference between each term, and in this case it's +2. Be careful that you don't get your signs wrong because it's an increasing sequence because you're adding 2 each time, so make sure that you don't forget the plus here. Okay, by just doing this, you've already done half of finding the formula. So whatever the difference is in this case, write it down and put n next to it. Now, why do I say this? I say this because if we say, okay, n equals 1, we put 2 down. If we put n equals 2, we get 4. If we put n equals 3, we get 6. If we put n equals 4, we get 8, and so on. The next step is to compare this here with this sequence. And we say, actually, how do we get from this back to the sequence? How do you get from a 2 to a 3? Well, you add 1. So all you need to do is to this term just add 1. And every single time it will work. Because if we put n equals 2, you get n equals 2. 2 times 2 is 4. 4, and you add 1 to get to 5. Okay? Let's try 3. So n equals 3. 3 times 2 is 6. And you've written down 6 here, but you add 1 and you get to 7. And it works for every single one of them. So if you want to find the 50th term, all you need to do is replace this n with 50. So let's work this out. So 2 times 50 plus 1. 50 times 2 is 100, and 100 plus 1 is 101. So the 50th term of this sequence will be 101. You can either sit there for ages, work out every single term until you get to the 50th, or you can follow the short method, find this formula and just plug in the value for n, which in this case is 50 because we're trying to find the 50th term, and here you get the answer. So let's take a look at another example here. We'll use the same steps to find the formula for this sequence, and then we will find the 50th term of this sequence. So step number 1 is to write down numbers from 1 all the way to however many sequences there are. So this is this term number to say, okay, 4 is the first term, 7 is the second term, and 10 is the third term, 13 is the fourth term, and 16 is the fifth term. The second step is to find the difference between them. Well, to go from 4 to 7, you're adding 3. To go from 7 to 10, you're adding 3, and you're adding 3 to every term to get to the next term. So you write down the difference, and the n automatically always goes next to whatever the difference is of the particular sequence. In this case, the difference is 3, so 3 goes next to n. The next step is to plug in different values for n and find out what results we get. So when n equals 1, we get 3 because 3 times 1 is 3. When we put n equals 2, we get 6. When we put n equals 3, we get 9. Then we get 12. Then we get 15. Okay, so it's essentially same as writing down the times table of 3, but make sure that whenever you do that, you're writing the first term underneath the first term of the sequence. So first term of the times table of 3 needs to be underneath the first term of the sequence. So just be careful. Don't accidentally put this 3 under the 7 because that will ruin your calculation. So then you compare these two and you say, how do you get from this to the main sequence? Well, the difference seems pretty obvious every single time. You just need to add 1. So to get from 3 to 4, you add 1. To get from 6 to 7, you add 1. To go from 9 to 10, you add 1, and so on. So you've already got your 3n because of the difference. And then you wrote down the times table of 3. And then you say, okay, how do you get from these terms to the terms of the main sequence? Well, you add 1. So all you need to do is put the +1 at the end, and that's the question done. And this is the formula, and all you need to do is plug in different values of n. You will be able to find out the term of the sequence here. So if you want to find out the 50th term, all you have to do is replace the n with 50. So 3 times 50 plus 1. 3 times 50 is 150, and 150 plus 1 is just 151. So in this case, the 50th term is 151. So this means that eventually, if you keep on carrying this sequence on, then the 50th term will be 151.